In this problem, we need to determine the equation of a parabola such that its focus is at 2, 3 and the directrix has the equation given by x minus 4y plus 3 equals to 0. Let us begin. So first what we'll do, we'll try to understand the problem graphically. We begin by considering a straight line. So here this is a straight line with the equation x minus 4y plus 3 equals to 0. Right. This is our directrix line. Now what we'll do, we're going to consider a line which is perpendicular to this directrix line. Now this particular line is going to be referred to as the axis of symmetry. This line is selected in such a way such that if we consider a point that lies on this axis of symmetry line, this will be referred to as the focus of the parabola. So here we have the focus of the parabola at 2, 3. Now to find out the equation of the line, we'll begin by considering a point P. Now P, let's say it has the coordinates h, k. Now this is going to be the locus of the parabola. The locus of the parabola is chosen in such a way, so if we join the point P and point F, this particular distance is going to be exactly equals to the distance of point P to the straight line, and this is the perpendicular length. So here let's say the perpendicular line drawn from point P on the directrix meets the directrix line at M. So this point P has been chosen in a very specific way. So here by the definition of parabola we can say that PF, this length must be equals to the length PM, the perpendicular length PM. Now we can easily find out the length of PF. So that's given by the square root of, so here we are going to use distance formula. We need is the difference of the x coordinate. So that's h minus 2, we're going to square this value and then add it to the difference of the y coordinate. So that's k minus 3 whole squared. So this will be equals to PM. Now PM is the perpendicular distance. So here let's go through the formula that we'll be using in order to find out the perpendicular length PM. So here we have a point P with the coordinates x1, y1, and we have a straight line with the equation ax plus by plus c equals to 0. If we drop a perpendicular from point P on the straight line, then the length of this perpendicular distance PM will be given by the absolute value of ax1 plus by1 plus c divided by square root of a squared plus b squared. So here a and b corresponds to the coefficient of the line ax plus by plus c equals to 0. Fine. So let's use this particular formula. So we'll take the absolute value. So inside the absolute value, we will first consider the coefficient of x of the straight line. So we have the coefficient as 1. 1 will get multiplied with the x coordinate of point P, so giving us h. Then we have the coefficient of y, so that's negative 4. Negative 4 will get multiplied with the y coordinate of point P to give us negative 4k. And then we have the constant term, that's plus 3, divided by the square root of, so we'll take the sum of the squares of the coefficient of x and y of the straight line. So we get 1 squared plus negative 4 squared. Fine. So what we'll do next, we're going to square both sides. Squaring both sides gives us h minus 2 whole squared added to k minus 3 whole squared. That will be equals to h minus 4k plus 3 whole squared. In the denominator, what we have is the square root of 1 squared plus negative 4 squared, which is 17. That means we have square root of 17, so squaring gives us 17. So what we can do, we can expand each of the terms and then simplify, so which I'll be leaving as an exercise for you to try out. It should give us 16h squared plus k squared minus 74h minus 78k plus 8h, this is k, plus 8hk plus 212 equals to 0. So almost done. Finally, what we'll do, we'll replace the value of h with x and the value of k with y into this equation, and that should give us 16h squared plus y squared minus 74x minus 78y plus 8xy plus 212 equals to 0. So this is going to be the equation of the parabola with focus at the point 2, 3, and the equation of the directrix given by x minus 4y plus 3 equals to 0.